So I'm Ben Strauss, and I'm a research scientist and vice president for climate impacts at Climate Central. We're a research organization that actually combines scientists and journalists. So we spend a lot of time kind of talking across that divide. I'm going to tell you today a little bit about sea level rise, the growing threats that it's posing to coastal infrastructure and populations, and also give you a preview of a tool that we're launching tomorrow. We launched our first surging seas analysis of national exposure to sea level rise in 2012, and now we're launching an updated version that uses much higher accuracy elevation data, kind of laser-based elevation data, and we expanded our analysis from from housing population and land to more than 100 different variables, and extended the tool in a bunch of ways. So I'm going to use it as a storytelling device as we go. So I just want to organize my remarks into time frame. I think when we talk about sea level rise and climate change, we often talk about what is coming in the future, but a lot has already come. We just don't always do the accounting to pick out the part that is climate change or the part that is sea level rise. And for some events, the accounting is very difficult, but for others, it can be a little more straightforward. So here's an image from Sandy. And here is a peek at our next generation, the map part of the tool, and a look at land in the New York City area less than 9 feet above the high tide line. That's how high Sandy got at the Battery, 9 feet above the high tide line. You might have heard 13 or 14 feet, and that's relative to the low tide line. So we've had about a foot, more than a foot, of sea level rise in New York City over the last century. Most of that was due to climate change. Most of it was climate related. There have been about 8 inches of global sea level rise over the last century. So we can look, and this is a very visual part. I just have a few slides I'm going to flash. So this is a map of 9 feet, but what happens when we go to 8 feet? There's a little difference. It's not huge, but it's clear. Now let's overlay the 9-foot map with population density. And let's move it back to 8 feet. So there's your difference again. Let's overlay the 9-foot map with property value and move it to 8 feet. There's your difference. So you can do some math now. And this is a crude exercise. This isn't the definitive kind of final scientific take on it. But I think it's a very useful rough take on what difference did sea level rise make to the damage that Sandy caused. So we can take the difference between land area, population, and property value between 9 and 8 feet in New York City and multiply it by 2/3 so that we're just counting the 8 inches that are climate-driven sea level rise, not sea level rise due to the sinking of land, which is also happening in New York and the region. And we see that just those 8 inches for New York City alone meant the difference in exposure for 75,000 people and about $9 billion of property. Doesn't mean $9 billion of damage, just means $9 billion of property, roughly, was sitting on land that got flooded because of sea level rise from climate, and it wouldn't likely have gotten flooded without that. So every single coastal flood today, and this is quite simple, every single coastal flood today is already deeper, already bigger, already more damaging because of climate-driven sea level rise. We just don't, we call it a flood, and we don't do the accounting to pick out the part that was climate related, but it's happening already today. In the spirit of advertising some of the aspects of the tool, I'll point out that I just showed the analysis for the whole of New York City, but you could divide that up. This is a map of New York City city council districts, a heat map showing property value less than 9 feet above the high tide, Sandy's level. You can mouse over any area, and you can see that in District 1, we have $15 billion, $15.5 billion exposed at that level. And you could do the same thing for congressional districts, state legislative districts, county legislative districts. So in this version of the tool that I know this is a kind of politics and business group, is my understanding, and in this generation of the tool, we were aiming to make it possible for a lot of different stakeholders and constituencies to tell stories. You can tell stories about exposure and impact by lots of different area types, by planning districts, by political districts, by zip code, by county. What's your unit of interest? You can tell that story. Okay. Now I want to shift to the future by looking at a fossil at first. This is some fossilized coral that's turned into rock. This is what the bedrock looks like under South Florida. So you can't build a seawall to keep out sea level rise in South Florida. Let's look at the future projected sea level rise in South Florida as just one example. Is that what's left, or is that perfect? Okay. Or is it's what's left, or how much I already used? So in Miami, for example, the dot on the map, there are $660 million of property on land less than 1 foot above the local high tide line. This is another view in the tool. Let's just slide it up and look at 2 feet, 3, 4 feet, and you can keep on going. We've got to $8 billion here. But using this information, we went a step farther in the tool and did a little math. We divided by, we figured out how much property was in each band of elevation, each 1 foot band, and how much land, and we looked at property value. And we found this very interesting thing, that if you're coming from a high elevation, property value gets higher per acre as you move towards the water in South Florida, as you would expect. But if the elevation gets too low, if you get too close, it drops off sharply, which makes sense. At the lowest elevations, you've got some wetlands. You've got frequent nuisance flooding from high tides. So you can't develop a lot. The property isn't going to be as valuable. But what this also suggests is that there is some narrow band of critical elevation in South Florida, where once floods start flooding that high with a high frequency, change is going to start happening quickly. The impact will be accelerated by this kind of steep change in property across elevation. So how risky is 2 feet? What's the story? So here we're looking at the forecast part of the tool, actually looking at flood risk statistics based on data from Key West, which is a ways from Miami, but it's got more than a 100-year record. So it's very high quality data, and it correlates extremely well with the shorter term records at Miami Beach. So it's a good proxy, and it's used in South Florida as a proxy for Miami. And what we're looking at here is annual flood risk. This is not a sea level rise projection. It's a projection of annual flood risk that takes into account future sea level rise. And it's annual flood risk of floods that exceed 2 feet. So by 2040, under the sea level rise assumptions here, and I'll get into that, you've got a 1 in 3 annual chance of a flood exceeding 2 feet. And you'll notice that the value is very low in 2020. It's just actually today in 2013, the value is just above 1%, maybe 2%. So you could buy a property today at this elevation which has never been flooded, or maybe hasn't been flooded in 50 years in memory. And by the end of a new home mortgage, it could be flooding every 3 years, according to this projection. Now this is using here, so NOAA led a federal multi-agency effort to develop sea level rise scenarios for input to the National Climate Assessment, which will be coming out pretty soon. The projections I'm showing you are from that technical report, and they gave 4 scenarios. This is the intermediate high scenario, so it's the second highest out of 4. But maybe we're interested in seeing how bad the risk is with a different scenario, so we can come in here and choose our model, choose our level. We're at intermediate high. Let's switch to low. The risk is lower now, just 8%, so once a decade, a little bit less. But notice that in both cases, there's a very steep transition across 2 or 3 decades from a low chance to really to 100% annual flooding. The timing of the transition is a little bit different. But the point is that there's a kind of double jeopardy here. The flood risk at a particular elevation is going to shoot up very rapidly, and that's a widespread phenomenon. And there's a kind of critical elevation zone where property exposure shoots up rapidly. So when those 2 things interact, you have a real acceleration of exposure that we might expect within the next few decades in some places. I'll also point out, we've been looking at annual flood risk, but another way to think of it might be total flood risk. I'm interested in the chance, not within 2040, but between now and 2040, of a flood exceeding 2 feet. And here, even in the intermediate low scenario, we've got about a 75% chance. I want to finish the discussion of the forecast by pointing out here, this is the way you almost always hear about sea level rise projections, what I'm showing you now. This is just the projected sea level rise in the intermediate low scenario, decade by decade. And you can see that it doesn't even get to 2 feet by 2100. So this is really important. If we used just the projected sea level rise, we'd say 2 feet, no problem. It's 100 years away. But it's not. The way we experience sea level rise is more floods reaching higher. That's what's happening now. In the long run, there's a serious danger of permanent submersion, but the story is not, report X just said we predict 1 foot of sea level rise or 2 feet of sea level rise by the middle of the century or the end of the century. The action is how sea level rise is increasing risks of flooding in the near and middle terms. Okay, so finally, everything. We live along the coast. We disproportionately pack infrastructure and assets along the coast. Everything is affected. And so just quick tour around the tool, back to the heat maps. Here's a map of high social vulnerability populations, less than 5 feet in New Jersey. By the way, they have twice the likelihood of being exposed, being at low elevation, than the population at large. So the more vulnerable you are economically and socially in New Jersey, the more likely you are to be in the flood zone. We're looking at by county here, but we can switch. Here's a look at power plants organized by congressional district and their exposure, ranked in the lower right-hand corner. Here's a look at EPA-listed sites. Now we're looking at municipalities within Hudson County, municipalities of basic governance, local governance unit in New Jersey. So we've got all of those in New Jersey. Pardon me, it's zip code. But we've also got it for municipalities. So here's a zip code look. Hoboken is the big city in Hudson County, so we can go to, get a great deal of detail about any particular city or state or unit that you want. So here's population exposure below 6 feet in Hoboken, different ethnic and racial minorities, or we can look at buildings, whether it's schools or hospitals or homes. We can look at infrastructure from road miles to ferry stations. We can look at contamination risks, a wide range of different EPA-listed sites that were screened for their potential risk to contaminate surrounding areas during a flood. So there's, and then at the kind of most granular level, we've made it, with this launch that's happening tomorrow, if you went on our website today, you wouldn't see this format, but it's switching to this layout tomorrow. You can download data, even lists of individual facilities at different elevations. So here are schools in Hoboken below different elevations. So there are a lot of stories here. We've actually already launched this detailed analysis for New York, New Jersey, and Florida. It's the web interface that's being updated for them tomorrow, plus a little bit new analysis. But the bigger thing we're doing is that we're releasing analysis for the first time for all of New England tomorrow, and through the rest of the spring and summer, we'll do the rest of the United States. And you can find it all here. Thanks for your time and attention.